Hello my 11th standard warriors, welcome to the lecture number 5 of rotational motion, and that is rolling and slipping. So we are going to see the kinetics and dynamics behind the wheels and the objects which roll, and what are the conditions for them to roll, and under what conditions do they slip. And the most interesting problem of today will be the one involving different rolling objects which roll down an inclined plane. So all of this with me, Shreyas, your physics master teacher at Vedantu, going live. Hi Gokulnath, Roshni, Aishwarya, Ishpreet, Rama, Darshan. Good evening my warriors. How is everyone? All excited? All done with your homework of the previous class? I hope you are all excited and ready. So those of you who do not know me, I am Shreyas. I am leading the physics department, JEE division, and training kids for more than like a decade. I graduated from NIT Nagpur. I did my research from IIT Bombay, and here I am on YouTube, the dedicated English medium channel for all the students across our country and even beyond our borders. Those of you who want to prepare with me, because I'll give you a few reasons why you should prepare with me, because many of my students had not just got into IITs and the top-notch colleges, but also aced in these exams with top all India ranks. So with this motivation, I hope you are all excited. I hope you all are geared up. Hi voice by Ram, Gokulnath is ready, and yes, if you have not yet hit the subscribe button, do that now. The reasons why you should hit the subscribe button is because you will get regular updates, you will not miss any of our classes, and also it will build our community, and many more students who would otherwise not be recommended this channel will get those recommendations. Yes, so that's why I always ask you to hit the subscribe and the like button. Now before we go ahead, a small announcement my warriors. Ragottanam, okay, yes, there has been a technical issue because of which the last two lectures PDF was not given. So don't worry Ragottanam, we will give you the last two lectures PDF. Don't worry, it will be done. Yep. So hi Abhivlia, I'm very good. Hi Akhil. Yes, I know it is not there in the Telegram group. I am aware of that. So don't worry, it will come up. Just give me a day or so, it will come up. Hi Sushruta, Vanakam. Silvai, welcome. I think your name was Remo if I'm not wrong. Yeah. So just in case, let's say you are not happy with your coaching. Let's say you just are probably in a school or college and you do not have any coaching, and you feel that maybe, yes, YouTube is working, but I need certain more things which I cannot get in my regular coaching, and I want the help of Vedantu, or I want to try Vedantu because you have some backlogs. Maybe you need some additional material, maybe you need teachers like us, or you need some conceptual understanding, you need some revision because almost half the year is over by now. So if you have that, let me tell you, in Vedantu Pro subscription, that's a subscription like Amazon Prime, Netflix, you get everything, be it revision, be it test series, be it assignments, be it KVPY, be it crash course, be it my modular courses, everything right at your fingertips. You just need a mobile device or a laptop, that's it. You can watch all the lectures. There is no need to go anywhere. In fact, we have shown this year and even before this and even before that, that sitting at home you can crack JEE. And many of our students have cracked JEE just by using their laptops and their mobile phones. So that's a testimony. So another reason why you should join right now is because today is the last day of 50% flat off, which is the educational fest on occasion of Children's Day. So this is a very amazing offer. The courses are for as low as the entire subscription for 15 days is just 750 rupees. So go ahead, use this coupon code SHHPRO and get 50% off and join the Pro subscription right away, because you can see the Pro subscription courses start for as low as 750 rupees, 50% off. You do not want to miss this. Even the higher packages are very, very reasonable right now. Tomorrow the prices are going to change. Thirsty, I'm good. I hope you all have done the homework. Hi Harita. Hello Suchi. Welcome. So let's just have a look at all the students who have done the homework, and then let's move ahead. I'll be also giving you today's homework towards the end of the class. Let me tell you that. So last lecture we did finding angular momentum and instantaneous axis of rotation. And like you can see over here, very good Sushruta, very good Harita. Glad you enjoyed the session. Chandan also enjoyed the session, but he watched the replay. That's okay. Good Ishpreet. You guys are very regular. Very good Yash. Glad you enjoyed the session. And Suchi has even posted the solution, and I think some mistake. And yes, so the PDF will be uploaded very soon. No problem, Saja. You watched the replay. Very good Dakshin. And very good Yash and Miss Abhirami. How to, oh, Abhirami, yes, I have to reply. I'll reply to you. Yes, I'm going to reply to you. I forgot to reply. Definitely, I'm going to reply. All right, chalo, let's get started. And what are we going to start with? See, we're going to first start with what is rolling, and then we are going to move towards the different variables, kinetics, and then the forces, that is the dynamics, and then the slipping part. So lots of problems on the way. So all the JEE aspirants join in. Do not forget to hit the subscribe and the like button in case you have forgotten. See, I'll explain you what rolling is. I'll explain you what slipping is in a very simple way. Imagine that you have some surface like this, and imagine you have a square or a polygon like that. This is the edge about which it is toppling. Okay, it is toppling. That object topples and falls. Eventually you will see that this square will probably come like this somewhat, okay, after it falls, but it continues to topple over. Then now it will topple over this edge, and what you will see is that the square or that polygon will start rotating like this about this edge until this edge falls over here, something like that, correct? And once this edge falls over here, it will topple over this edge. Now this is okay for a square or a small sided polygon. What you are seeing over here is that every time it topples over the edge, which is right over here, this edge is basically at rest, and the entire object topples over it. Similarly, try to think of a multiple sided polygon. Maybe there are many more sides like this, okay, something like that, and right now it is toppling over this edge, and again this point will come over here, and then again it will topple over this edge. Again you will see after some time this point will come over here and it will topple over this edge. So if I keep on increasing the sides of the polygon, think what will happen if I make the number of sides infinity. What is that figure called when the number of sides are infinity? What is that figure called when the number of sides tends towards infinity? This is nothing but a circle. Now if you have a surface, this is like a polygon with many sides, infinite edges. Right now it is toppling over this edge. So this edge is basically at rest. I hope you can see that, and it is basically toppling over it. Just at the very next moment, what are you going to see, my warriors? This next point, which is hardly any distance, dx, will be over here, and now this is the point of contact, and it is toppling over this, and this point is at rest. At the next instant, a new point of contact will be there. The circle would have moved ahead and it will topple about that point. At the next instant, new point of contact. Again the same story repeated. So it's nothing but that point of contact is at rest and it is toppling over again and again. This phenomena is basically called as rolling, where the edge, the point about which it topples or it the point about which it rotates is at rest. That's what it is. Yeah. Now imagine a situation where as this polygon topples, this edge is not at rest. I'll give an example. Let me make use of my iPhone. So why do you use iPhone? You use iPhone for showing demonstrations to kids in a physics class. Okay, so those are one of the uses of an iPhone. So imagine this is a surface and this is a polygon obviously right now, and imagine this edge this edge is sliding, and as it slides it topples, and as this next edge comes it again slides and it topples. So it is sliding and toppling. So that edge about which it is toppling is also moving, then it is called as slipping motion. It's not rolling. So that edge about which it is toppling is not at rest. That edge itself is sliding over that surface. Then it is sliding motion. I hope this is clear. Oh no, Gokul, this year there are no stocks available, no iPhone 13, no Apple Watch. I tried to order Apple Watch, but it is not coming. So I tried from all the places, US, Canada, Dubai, everywhere. It's not there. It's just not there. Thank you, Sushruta. I'm so glad, and I really hope you continue scoring even better. Glad to know that. Very good. Keep it up. Keep it up. So pure rolling is what we're going to do first, and then impure rolling, or basically slipping or sliding motion. Okay, so that's what we're going to do. So we're going to study both kinds of motion. Now let me tell you, there is a very beautiful way of looking at rolling. Hi Ria, welcome. Hi Roji, good evening. Yep. Rolling is the sum of toppling? No, rolling is actually toppling about new edges. So you can think it is toppling over and over again. Yes, so it is summation of toppling, all the topplings together. But there is another way of. Yep, Harita, correct. I think you just mentioned that, whatever I said. Yes, hi Amir, hi Sanjoy. You can also look at rolling as a sum of two things. And what are those two things? Number one, rotation. Number two, translation. Yep, I'll tell you how to look at it. Imagine this is my hand, and I take this hand and I rotate it. Okay, and I rotate it. Right now my hand is only doing rotational motion. This point has a velocity omega r. Omega is my angular velocity, r is the length or the radius of this circle. Okay, length of my hand or radius of the circle. So the velocity of this finger over here is omega r. That's pure circular motion or rotational motion. Now I just hold my hand like this and I just move. Okay, I just move from one end to the other. I just move holding my hand. This is translation motion, because the point is just moving with my velocity. It's just moving with my velocity, isn't it? Now I do both the things together. So I'm not just going to move from one side to other side, but I'm also going to do the circular motion action. So when I do this, what's going to happen? These points will not only have their circular velocity components, but it will also have the linear motion added to it. So two things together combined will become rotational motion, or rather I would say rolling motion. Look at this. This is a beautiful simulation. Okay, let's just start over from again. Okay, this is just a rotation. Look at this. This is just a rotation. Now I'm adding just translation. So now rolling is nothing but translation plus rotation. You can see that beautiful simulation. Look at this. So this is just pure rotation. This is pure translation. But in a very peculiar way, if you combine both of them, it goes forward. At the same time, it also rotates. So that's rolling. There is difference between rolling and rotation. Rotation is just about that axis. Rolling, the axis also moves. Okay, the axis also moves ahead. You can see that. Now, that's what pure rolling is. And like I said, in rolling motion, okay, in pure rolling motion, the point of contact between the body and the surface is at rest. Very, very important point. This is the pure definition. This is the exact way in which you will check if something is rolling or not. That means, like I just showed you, the point of contact should be at rest. This is the edge about which it is toppling. This point should always be at rest. Now, in order to get that, there is a very easy way. Just imagine this is circular motion. Okay, this is circular motion. And in circular motion, if this axis is at rest, each point on the circumference will have tangential velocity. I'll just call it as Vt. So they will all have Vt, which is tangential velocity. If I do not rotate the circle, if I translate it, okay, if I translate it, that means if I just move this axis straightforward, all the points will have the same velocity as that of the center, or basically the axis. So this is just VC all over again. This is pure translation. Now if I add or combine both the motions, that's what we saw. What you're going to get is, see, this point is having tangential velocity. Also, due to the center, it is moving forward. So in effect, it will have V tangential plus V center. The center will also move. Yes. So both will move in the same direction. So both of them, when added, both of them in the same direction, the net speed of the topmost point will be Vt plus Vc. Are all the tangential velocities same? Yes. Magnitude wise they are same, direction wise they are different. Thank you so much, Aishwarya. Thank you. Okay. Okay, that means a lot. That means a lot. Ankita, very good. Nice to see you back. Yep, looks like you're on and off these days. Let's go ahead. So, what about at the bottom? This point is moving forward because of translation. But at the same time, due to tangential velocity, it is moving backward. So, the total velocity that it will have will be Vc forward. So it is moving forward with Vc and minus Vt. So the subtraction of the two, because due to the central axis moving forward, it is moving with Vc, but it came back behind by Vt amount. Great. What about this point, which is over here? It has two components. Remember, it has two components. One is Vc and the second one is Vt. So that's why the net velocity of this point is somewhere here. Think about it. The center will make it move this way. Tangentially, it is moving up. So the combination of these two together, will be here. Same way for this point. Okay, it's moving forward. But also going down. Okay, it's moving forward and it is also going down. So the total velocity of this point will be somewhere over here. That's how it works. Ankit, you should set up some filters. You should also make sure that you watch YouTube lectures on full screen and not go to the recommendations below. Yep. Thank you, Gokulnath. Glad to have such a young student like you, like always. God bless you. Yep. So now here is the catch. In rolling motion, the point of contact is at rest. That means this point, which is a point of contact, should be at rest. That means this should be 0. Isn't that correct? This point should not move forward or backward. That means this total velocity should be 0. That means Vc should be equal to Vt. That means Vc, velocity of the center, will be Vt. What is Vt? Tangential velocity. What is tangential velocity? If this is r and this is rotating with omega, Vt is nothing but omega r. Hence, Vc will be equal to omega into r. As simple as that. That's it. So, only when this condition is satisfied. Where did I get this condition from? I got this condition right from this particular statement. What this statement is telling is, when the center's velocity is omega r, then it will do pure rolling. If it is not equal to omega r, then it will not be pure rolling. It will be slipping, skidding, some kind of slip will occur between the surfaces. That's what is very important. Only when this condition is obeyed, it will roll. When this condition is not obeyed, I am repeating again, when this condition V is equal to omega r is not obeyed, it is going to slip. It will be impure rolling, or it's basically not rolling. Okay, so very, very important. So the rotational velocity at every point, the tangential velocities and the translational velocities combined together gave me the total velocity. For pure rolling, the net velocity at the bottom is 0. Okay. My question to all of you is, if Vc is equal to Vt, which is also equal to omega r, then my question to all of you is, this topmost point, the velocity at the topmost point, okay, what do you think this will be? What is the velocity at the topmost point equal to? Think about it carefully in terms of VC or omega. This is going to be very interesting. Remember, this point not only has the center's velocity but also has the tangential velocity, because that point is going that way and the center is also taking it that way. So what will be the total velocity? V center, which is omega r plus omega r. That's it. So it will be 2 omega r or 2 times of Vc. So this point has 0 speed, this point has Vc speed, this point has twice Vc speed. What an interesting trend over here. 0 because it is at rest. This point is just translating, there is no tangential, okay, just Vc. Okay, so very interesting. This only has basically center's velocity. This point has 2 Vc, double the velocity. What an interesting trend that you're seeing out here. So the speeds at different points are different in rolling motion. Yep, you see a car's wheel moving. Trust me, all the points have different velocities. Bottom has 0, the topmost has double the velocity as that of the axle. Interesting. So just imagine if you have your bike, car, whatever. Okay, this is the wheel of your bike maybe. Okay, this is your handle, whatever. And your bike shows 60 kilometers per hour. So the center is moving at 60 kilometers per hour. Okay, 60 kilometers per hour. This point is at rest and this point is moving at 120 kilometers per hour. Interesting, isn't it? The topmost point is moving at 120 kilometers per hour. What a beautiful concept. Okay, now let's go to the first way in which we discussed rolling. First way in which we discussed rolling, and that was basically toppling over an edge. So basically the entire object, when it rolls over that edge, it topples over the edge and the edge is at rest. So if you think about it carefully, any polygon which is, toppling and rotating over this edge, this is the edge which is basically at rest, it is basically toppling. Can I not say this axis is basically the axis of pure rotation? This is the axis of pure rotation. All the points are just going around in circles. Just visualize this. All the points are just going around in circles about that point, isn't it? So that should be also true for a circle which has infinite edges and it topples over every successive edge. So just imagine if you have a circular object which is rolling, this point is basically at rest. So point of contact, the point of contact is basically at rest, and not just that, the point of contact is also the axis of pure rotation. And if it is the axis of pure rotation, all the points are going in circles around it. Yes, all the points are just going in circles around it. That means it's very easy to figure out the speed of any point. How? Remember my previous theory, axis of pure rotation? I just gave it to you. So if you have not attended that class, please watch that class. It's very important, axis of pure rotation. So think about it. Any point's velocity can be found by joining a line from that axis of pure rotation, dropping a perpendicular, and that velocity will be perpendicular. If this is r, this v will be omega into r. As simple as that. So a point here, okay, this is the distance, this will be the velocity. It will be slightly more because this distance is more. A point here, okay, if you draw a line like this point will have a velocity this way. This is, I feel, easier to find velocity rather than combining translation and rotation. See, in rotation and translation combined, you have to think, okay, this point, it was moving tangentially like this. Okay, it was moving like this. So the vector addition will give me the total velocity. This is how you would get if you combined or separated translation and rotation separately and then you added their vector sum. But this is so easy. You just draw a line and drop a perpendicular. V is equal to omega r. As simple as that. Sir, r is position vector or radius? R is the position vector. over here. Yep, r is the position vector, but you can think, yes, it is also the radius as well in this case for the axis of pure rotation. Okay, so it happens to be also the radius. So what this means is that if you look at the wheel in a very different way, something like this, where the bottommost point is your nothing but axis of pure rotation. Okay, instantaneous axis of rotation, whatever you want to call it, instantaneous axis of rotation. Then all the points are going in circles. This point will have a velocity. This point will have a velocity v, which is equal to omega, the omega into r, which is true. I mean, it is true. V is equal to omega r, only then it will roll. This point over here will have a velocity omega into this distance, which is 2r. Look at it, it is so easy to find the velocity. This point over here, this distance, and that will give me this velocity. Remember, if this is r, this is r, this will be root 2 times of r. Pythagoras, correct? You can see a triangle being formed over here. This is 90 degrees. So if this is r, this is r, this is root 2r. So how much will this velocity be? This velocity will be omega into this distance, which is again root 2 into r. It is so easy to figure out the velocities. Sunita, very good. Don't spam bacha. BSc नहीं होती क्लास, यहाँ पर होता है 11th and 12th का क्लास. Okay, is that clear? This is how you find the velocity at any point. This is the second approach. What is the first approach? Write translation and tangential separate and do the vector addition. Second approach, use axis of pure rotation and find the velocity at any point. Isn't that clear? Yep. So both the ways you will get the same answer. I'm not saying you'll get different answer, you'll always get the same answer. Okay. Not just this, let me also tell you one more thing. When a sphere, a shell or whatever cylinder rolls, if this is the velocity, this is the angular velocity. Let's say the speed changes. That means it has some acceleration. If it accelerates, even the rotational speed will change. So it will also have angular acceleration. Now we know for rolling purposes, velocity is omega r. So differentiating, that means dv by dt is equal to d omega by dt into r. dv by dt will be a, d omega by dt will be alpha, and a will be equal to alpha r. So both these relationships hold true when it is rolling. So the linear acceleration will be angular acceleration into r only for pure rolling. Okay, not otherwise. If it is not rolling, then yep, definitely it will not be true. Very, very important slide. Please note it down. It should be all there in your books. I hope you are making notes as you are observing and watching this lecture. Okay, so let's move ahead. Okay, chalo, let's start solving some questions. And here we have the first questions. Thank you, Chari Sanjay. Thank you. Welcome. Nice to see you in the live class. Very good. Chandan says clearo. Google Nath says easy peasy. Aishwarya also ready. Very good, Suji. Very good. Siddhartha Kunguli. Yep. Here we have a wheel which is moving with speed v, rotating with omega. It also has acceleration. Do not forget that there is acceleration. Question is find the velocity and acceleration of this point and this point. Okay. Very interesting question. Is x equal to r theta? Yes, Sushrut. Yes, definitely x will be equal to r theta. Okay. I think the first part is easy where you have to find velocity. So finding velocities is very, very easy. Think about it. Because it is mentioned that it is rolling without slipping or basically rolling. So because of this condition, it means that the velocity of point of contact should be 0. What is the point of contact? A. So VA should be 0. That's it. This is the first answer. Of B point, that is also easy. We all know this point can be joined from the instantaneous axis of rotation. It is rotating with angular speed omega, and this velocity can be easily found. The velocity of point B will be omega multiplied by that distance. What is omega? Omega is V by R. Omega is V by R, or if you don't like this, it's okay. Just put omega as it is. And what is the distance? Distance is 2R, but omega R is V because it is rolling. So omega into R is nothing but V. So 2 into V, that should be the answer. Very good, Chandra. I think we just did that. So velocity of point B is also done since V is equal to omega R because of rolling. Cool. Now the tricky part is acceleration. You will see why. Okay, the acceleration of point A and point B. Now this is very tricky. Let me warn you in advance. This point's acceleration is not so easy to be found. So for this, I am going to, use a relative method, relative frame of reference. First, I will sit on the center. I'll sit on the center and then look at point A. If I look at point A, I will just look at it as if it's doing circular motion. Think about it. If I sit on the axis, I'll just see it doing circular motion. And me, myself, the center, is moving with speed V and acceleration A. So let me use this definition. Acceleration of, A with respect to C. Acceleration of A with respect to C will be acceleration of A minus acceleration of C. This is pure definition which you have studied in relative motion. A12 is A1 minus A2. V12 is V1 minus V2. That's it. So AC is AA minus AC. That means acceleration of A will be acceleration of A with respect to C plus acceleration of C. Why am I using relative? Because it's doing a very complex motion. Let me tell you, this point A will go like this. The accelerations are not so easy to be found. Remember, I'm not talking about the center's acceleration, I'm talking about some random point's acceleration on the wheel. That's why. Now, yes, it is losing contact, it's accelerating upward, it is also moving forward. It's not so easy. Now, let's look at it one by one. Acceleration of A with respect to C means just consider circular motion. Just consider circular motion. Because when you sit on this point C, you are just going to observe circular motion, correct? And AC is nothing but acceleration of the center. That's it. I think I can solve this individually. First, let's look at this part. This point A is performing circular motion, so it should have centripetal acceleration. Everybody agrees? So it should have centripetal acceleration. Not just that, its speed is changing, omega is changing, so it should also have tangential acceleration. Think about it, it should also have tangential acceleration. And if I stick to this terminology where this is x-axis, this is y-axis, think about it, this acceleration will be this first term. Two components, centripetal and tangential. Centripetal is here, tangential is here. Centripetal is in y-axis, tangential is in minus x. So, the centripetal will be plus omega square r j cap. Why omega square r j cap? Because j cap is in this direction. Omega square r is the value of the centripetal acceleration. AC, will it be constant? Well, if this A is constant, then yes. No. Actually, omega will keep changing. So that's why it will also keep changing. So at this instant, you can find it Suchi, but at some different instant, it will be different. Artist, Arihant, be careful. mv square by r is mass into acceleration, not acceleration. Be careful. So omega square r plus j cap. Tangential is negative. And how much is tangential? Remember, it is alpha r. If you recollect from your circular motion days, it is alpha into r I cap. So this is just the first term. This is just the first term. The second term, the center's acceleration is already given. The central acceleration is a. This axis is moving with acceleration a. So just a I cap. That's it. Now we all know, because it is rolling, when it is rolling, a is equal to alpha r. So I can get rid of alpha and I can write it as a by r and so on and so forth. You can, if you don't like omega square r, you can also write it as v square by r, one and the same thing. Okay, omega square r or v square by r, one and the same thing. So it will become v square by r j hat, and alpha r is nothing but a, so minus a I cap plus a I cap. Oh, both of them cancel, so I'm just left with v square by r j cap. That's it. So that's the acceleration of point A. Is that clear? Yep. So Sunita, you can tell me what you did not understand. I'll definitely help you. Okay. So why is A equal to alpha r? I just give it to you. Since V is omega r, differentiating it, A is equal to alpha r. Yes, that's it. So that's why A is equal to alpha r, and alpha r and A will get the same. So it will get cancelled and you will get this answer. Beautiful. That is the next answer, but we are not done yet. We have to find the acceleration of point B. Okay. Are you guys ready to find the next answer? Let's do this. It's very similar. I'm just going to erase this. I don't need this anymore. Okay, starting over again. In order to find the acceleration of point B, again go by the definition. Acceleration of B with respect to C will be acceleration of B minus acceleration of C. You can just rearrange this and you will get acceleration of B will be acceleration of B with respect to C plus acceleration of C. This part is nothing but circular motion. This is nothing but circular with respect to C. This is nothing but linear motion of C. Now, when you sit at C and look at B, and you sit at C and look at B, think what and all accelerations will you get? B is going in a circular path, so obviously there will be centripetal and there will be tangential like this because it is rotating like that. So tangential acceleration, centripetal acceleration. Cool. So what and all terms will we get? This first term, tangential acceleration will be nothing but alpha r, correct, I cap, because alpha r is the tangential acceleration. Centripetal will be negative v square by r j cap. Fair enough. So this term is done. Okay, I'll put it in the bracket. Last term, the center's acceleration. What is the center's acceleration? It is given to be a. So just a I cap. Solve this. Alpha r is nothing but a. So this is a I cap minus v square by r j cap plus a I cap. So this will become 2a I cap minus v square by r j cap. So that's the answer. What a brilliant question. Is this understood, my warriors? What a brilliant question. Okay? So that's how you solve questions on rolling motion. So we have also coupled the relative motion. So that's why I keep saying, please make sure your chapters are brushed up, the previous chapters. You cannot skip any chapter. If there is any student asking to any one of you, even your friend, and if they tell, can I skip momentum for rotation? No. Can you skip circular? No. Can you skip vectors? No. Can you skip Newton's laws? No. Can you skip work per energy? No. Can you skip center of mass? No. You cannot skip any chapter. Let's solve the next question. Nandini, you can watch the replay again little bit. Okay? That will help you. Okay, Nandini? Just go. Even in a live session, go little behind. You can watch it. Thank you, Jayatirtha. Oh my God, practical maths. You're a little bit late, but it's okay. Just join in. Even in a live session, you can go back, catch up at 2x speed, and then watch it properly. Yeah, that's what you can do. Let's solve this question. Wow, how many of you have done this? This is exactly this question. There is a sphere and the bottom plane is moving this way with 2v speed. The top plank is moving with speed v. So there is a object, spherical object trapped, and you are moving it like this. So the question is, what is the velocity of the center and the angular velocity of the center? Sphere. So those are the questions. It's a beautiful question. Let's try to solve this. See, one thing you should know, since it is rolling, what does it mean? The velocity of point of contact, is 0 with respect to the surface in which it is making contact. So if there is a point, it's not moving with respect to the surface. So if you see a sphere rolling on the earth's surface, yes, the point of contact is at rest with respect to earth, But if you go outside, even the earth is moving. So the point of contact may appear to move, but don't get scared. Understand the relative motion is 0. Okay, great. Now, if that is true, then it makes sense for me to say that this bottom point is moving left side with speed 2v0 because the plank is moving with speed 2v0. Think there cannot be slip over here. There is no relative motion. If there is no relative motion, this point should also move with the same velocity of 2v0. Make sense? It should also move with 2v0. Also, the topmost point over here, is not going to have any slip. So it should also have a same speed as that of the plank. There should be no relative velocity. So this point should also move with 3v0. There is no negotiation in that. Now, I don't know whether it is B or whether it is C. Let's figure this out. The next thing that I'm going to do is, let me assume few things. Let's say the center's velocity is v and the angular velocity is omega. So because of that, this point will have a velocity. How much velocity? This point on the top will have a velocity v plus omega r. Make sense? This point will have a velocity v plus omega r. Omega r is the tangential velocity. Remember, the tangential velocities will be like this: omega r, omega r, omega r, omega r. These are all the omega r's, tangential velocity. So the total velocity will be v plus omega r. Fair enough? For the bottom, think it is going behind. So tangential velocity is behind and linear velocity is forward. So this point's total velocity will be omega r minus v. Many people make a mistake and they write v minus omega r. There is a catch here. It should be omega r minus v. Okay, see if this is clear. Why is this omega r minus v? Because again, I'll repeat. This point is moving tangentially behind with omega r, but the center is pulling it forward with speed v. So the total net velocity will be omega r minus v. So it's actually moving behind. It's actually moving behind. The net actual velocity. See if this makes sense. See if this makes sense. Is this okay? Is this clear? Because if you get this, only then we can go ahead. Very good. Now, if this much is understood, just make the equations. Over here, there is no relative motion, right? The red and the green are actually the same things. There is no relative motion. So actually speaking, 3v0 is v plus omega r over here. And here, think about it, 2v0 is actually omega r minus v. So what do you do next? Obviously, add both of them. So 3v0 plus 2v0. So 3v0 plus 2v0 is equal to vv goes, so it will become 2 omega r. So 3 plus 2 is 5. So omega will be 5v0 by 2 into r. So that's the first answer. And once you get omega, you can use it over here. So from this equation, 2v0 is equal to omega, which is 5v0 by 2r minus v. So what will that give you? V is equal to, so v is equal to 5v0 by 2r minus 2v0. So 2 2s are 4. So it will become, 1 second, I think I forgot one r over here. Yeah, sorry, there was an r here. I forgot that. Yeah. So this will become just 5 minus 4, which is 1. So v0 by 2, I suppose. So is it there somewhere? v0 by 2 and 5v0 by 2r? Yes, 5v0 by 2r and v0 by 2, which is option A. Chaitra, don't worry. I will try to make sure that your previous account is unblocked. Okay, don't worry, don't cry. Okay, don't worry, you'll get unblocked. Yes, by mistake it might have happened. Thank you, Godson OP. Love you too. Thank you for all the love. Thank you for all the love. In fact, one of our teachers have just visited Nepal and he is posting pictures and making me jealous. He's just done some skydiving from the helicopter and it's crazy. I was just seeing some pictures of Nepal. It's crazy. All right, so that's the answer, option A. Let's move to next concept. Dynamics. In dynamics, apart from velocity, acceleration, you will have forces, torques. So when you have a sphere, when you have a disc, when you have any cylinder which is rolling, there will be multiple forces acting on it, and some of the forces have already been shown. Look at it. mg, which is the weight, normal at the point of contact, friction will also be there, and it might have certain acceleration, and it might also have some angular acceleration. So let's say there might be some other forces also. I don't know, maybe some random force from somewhere, maybe some another force F is also there, maybe at certain distance x. If all these things are there, what will you do? Just solve it like a Newton's law problem. That's it. That's it. Just solve like a Newton's law problem. What does Newton's second law say? Net force is mass into acceleration. Just do that. So in the y direction, can you see there is only normal and mg? So can I say normal minus mg is 0, or rather normal is equal to mg? That's all you can do. Next, you will write down, in x direction, there is this force F, and I think there is friction also. So these two forces are there horizontally, and that is why it is accelerating. So all you have to do is, you are going to write, F plus small f is equal to m into a. This is one equation, this is second equation. So just make equations, that's all. And then you can also make torque equations. What is Newton's law for torque? Net torque is moment of inertia into alpha. So what are the forces which are causing torque? Think about it at the center. If you sit on the center and look at this axis, what are the forces which are causing torque? mg, definitely not, because it is passing through the center. Normal is also passing through the center. So mg and normal will not cause torque. I hope that makes sense. So mg and normal don't cause any kind of torque. That's very interesting. Is this force causing torque? Yes, you can see that clockwise. Can you see that clockwise torque? R is x, force is F. So you can just write x into F. Then what other force? Oh, this friction is also there. Can you see that? So this friction is at a distance capital R, and that friction is giving anti-clockwise torque opposite to alpha. This friction is trying to rotate it anti-clockwise. It's not helping alpha. So it is minus R into F. This is equal to moment of inertia into alpha. That's how you will write the equation. And one more equation you will need, and that is nothing but A is equal to alpha R, because it is rolling. So solving these equations, you can find any unknown forces. Is that clear? So all that you have to do is solve it like a normal Newton's law problem. Draw the FBD, write F is ma, write torque is I alpha, and remember A is alpha R. That's it. Solve it, you will get it. Now there is one catch. None of you questioned me, sir, why do you take friction forward? I thought friction was backward. That's right. I do not know, in fact, where is friction. In fact, you will always assume the direction of friction. That's the tricky part. Most of the times, you will not know. There are certain cases where you can find it out logically by some elimination or some logic. Physics logic, not elimination logic, physics logic. So, unless and until you are confident, you can just assume anything. And if you are wrong, let's say this direction is wrong, your answer for friction will come out to be negative. So after solving all this, if friction comes out to be minus 7 Newton, what does it tell you? It just tells you whatever direction you assumed is wrong, actual friction is this way, and the magnitude is still 7 Newton. That's it. I hope that is clear. I hope that is clear. Very good, Chandan. Don't worry, Sushruta. Oh, your love matters to me more. Thank you, Aishwarya. Very good, very good, very good. Suchi, very good, Sunita. All right, so let's solve some questions based on this. So I have given you some theory as well. The friction of the point of contact, number one, is static in nature. Why is this static? You should question yourself and convince yourself. Why is the friction static? Because there is no relative motion. Remember that there is no relative motion between the point of contact and the surface. So it has to be static. No, Sushruta, think about it. friction opposes relative motion that is in kinetic friction. The whole problem is this is static. So what will static friction oppose? When there is no motion only, it will oppose the tendency of motion. And that you do not know because you cannot ask, hey, where is your tendency? What's your bhavna? Where do you want to move? It won't tell you. So you need to solve the equations to understand the bhavna. I hope that makes sense to Shruta. So that's why you assume it, and whatever direction comes, by the equations you get it. Use the laws and find all the unknowns. Okay, torque equation, force equation, whatever you want to do. Okay, and one important thing, this static friction will not perform work. Why does it not perform work? Remember, work is force into displacement of the force. Very, very important. Displacement of the force into cos theta. This friction which you see is acting at that point, and this point is at rest. If this point is at rest, this displacement of the force is a big zero. Hence, the work is also zero. Keep this in mind. Yep, displacement of the force. Divya joined in late. I think you guys have missed my timing. My classes are always at 7:30. So always join at 7:30 unless you have some other class or maybe you are occupied somewhere or something else. So try to join in at 7:30 so that you do not miss any of the fun and you build up the concept right from basics. Very, very important. Okay. So work done by static friction is zero. Keep this in mind. Okay. Let's start solving some questions. Hi, Super Ricky Star. Join in. Here's the first question. Let's see how many of you can do this. We have a cylinder of mass m, radius r, and it is pulled horizontally from the center with force F. What is the correct direction of friction? Now in the options, this force has slightly come on the top. Ignore that. Actually, this force should be at the center. Okay, it should be directly at the center. It has just been printed little bit incorrectly. So refer to this diagram. Think where the friction will be. Will it be left? Will it be right? Cannot be determined. Or will it not be there? Okay, just see. Come on. Figure this out. Come on. Okay, many of you are saying B. Okay, let's see how many of you can get this correct. Dakshin saying option C. I don't know whether it is B, C or something else. All right, let's figure this out. First of all, what are the forces acting on it? Obviously one normal will be there and obviously mg will be there like this. Because of this force, obviously it will move this way. If it moves that way and it has to roll, think if you are pulling it from the center, it is going like that, it's going like this. So it has to also have some kind of angular acceleration. Now think, using your torque equation, net torque is equal to I into alpha. This alpha is clockwise. Who are the forces which can give torque? Maybe normal, maybe mg, but we know normal and mg are passing through the center, so they cannot give torque. So strictly speaking, this normal and mg are not giving torque. This force F, well, that's the next contender, but unfortunately that force F is also passing through the center, so that also cannot give torque. That means there must be only one force which is giving that torque. That means that should be friction. So the last force is basically friction. And since all these terms are zero, hence this torque must be clockwise. Correct? The torque must be clockwise because alpha is clockwise. Now, how will you show friction to get it clockwise? Will you show friction right side or will you show friction left side? Obviously, if you show right side, it will create anti-clockwise torque. If you create friction this way, then it will create clockwise torque. So hence, this will be correct, this will be wrong. So option A, I believe. Is that clear? Is that clear? Yep. Is that understood, my warriors? Yep. Very good. Very good. Very good. Excellent. A option is correct, like you can see. Yep, it has to be towards the left. What a beautiful question. So this is how logically you can determine friction's direction. Let's do one more question like this. Good evening, Satvik. You have a plank. There is a sphere on it, cylinder. Okay. You pull the plank. Beautiful question. You pull the plank, it will start rolling like this. It's free. Okay, there is roughness on that. So you will see it will start rolling. The question is, what will be the direction of friction? It's crazy. I'll give you a hint. Make use of non-inertial frames of reference. Yes, that will help you. Pseudo force. Try to do it via pseudo force. It will help you. Sit on something, observe the other, and it will make you get a feeling, and you will probably get some equations, or maybe you will be able to draw the FBD and then get the correct answer. Very good, Suchi. Very good, Aishwarya. All right, come on, my warriors. Very good, Sushruta. Let's do this. Come on. Think. Sit on maybe the plank, then observe the cylinder, draw the forces, and see who is going to give the torque. You will see, then you will be able to judge the correct answer. Okay, beautiful question. The plank below is pulled with force F. The cylinder starts rolling. What is the direction of the friction? Going to B. Okay, many of you are saying B. Interestingo. Now looks like the hint has worked, maybe. So if I choose a non-inertial frame, so this plank frame is basically a non-inertial frame, and this non-inertial frame has acceleration towards the right side because the plank is pulled there. So obviously when you sit on the plank and look at the cylinder, there will be a pseudo force. So there will be a pseudo force like this, and obviously there has to be a normal, and there has to be mg. Friction I do not know yet, so I'll just keep it aside. So the torque by normal plus torque by mg plus the torque by pseudo plus the torque by friction will be I into alpha. Very interesting. Now if you pull it like this, what will happen? It will start rolling like that, right? It will start rolling like this. Does it make sense? It will start spinning this way. Think about it. If I pull it this way, okay, it will start going that way. It will roll like this. It will have alpha like this. So this alpha is this way. If this alpha is this way, and I also know normal does not give torque, mg does not give torque, pseudo force is also passing through the center, so that also cannot give torque. The only force which can give torque is friction, and if this is this way, anti-clockwise, this also has to be anti-clockwise. Now if this has to be anti-clockwise, there is only one way friction can be. That means the friction should be like this. This is how friction should be, so that it can help alpha. And that means correct option will be B, which is very good. Very good, very good. Okay, Yash, I already have a class at 5:30, and the 12th standard classes usually are conducted at 5:30, and yeah, it's difficult to keep the class at 5:30 because most of the students get free at 7:30, so the class timing will remain 7:30. You can watch the replay just in case you are not able to attend live class. Next question. Let's do this. Okay. Now, in this question, there is a numerical value that you have to find. There is a force F on the topmost point on a sphere. And the question is, if the ground is rough, there is no sliding, that means it is rolling. What is the acceleration of the center? Obviously, options are there, but don't look at the options. Start with the FBD, that's it. Always start FBD, F is equal to ma, torque is equal to I alpha, start solving. Let's see what and all equations you are getting. And let's see if it matches with my equations. One force is F. The other force that will act is obviously mg. So mg will be down. Normal will be like this. And friction, I think I do not know where is friction. So I'm just going to assume. It's not so easy to find out the value of, direction of friction because the force is acting from the top. So I don't know. I just assumed it here. Well, there is also acceleration and there is also angular acceleration. It's just like you have a surface, you apply a force on the top. You can see the spherical object starts moving like this. Okay, you are just applying the force on the top. Great. Now getting a hang of the direction of friction. Now very good, Roshni. But in this problem, there is, I don't know where the friction is. I don't know. Very good, Sidala Kunbuli. Great. Now, let's just write the equations and see what do we get. If I write net force is ma, okay, net force is mass into acceleration. What are the equations I'll get? The topmost force plus the frictional force, normal mg is vertical, is equal to mass into acceleration. So F plus F is m into a. Great. Next, net torque is I into alpha. Let's see what do we get using that. About the center, normal and mg are not giving any torque. The force F is creating clockwise torque, which is helping alpha. So the torque by that capital F is assisting alpha, that means it should be positive. So plus R into F, R cross F, and the R value is this one. Remember, R into F, sine 90 is 1. Okay. And this friction, you can see about the center, is creating anti-clockwise torque. Look at this. This friction is creating anti-clockwise torque. It's opposite to alpha. It's opposing alpha. So I'll put minus R into small f is equal to moment of inertia. What is this? It's a sphere. Okay, so solid sphere. So it will be 2 by 5 mr square. That's moment of inertia into alpha. Okay. Wait a minute. I think I know what alpha is. Because it is rolling, V is equal to omega r, and I also gave you one more equation, and that was A is equal to alpha r. Remember that? So I think I'll make use of that somehow. But before that, let me cancel few things over here. R, and one of the R goes. Do you see this R and this alpha? So from here, alpha r is nothing but A. So that's what I'm going to write. So F minus F is equal to 2 by 5 m r into alpha. Alpha r is nothing but A. Beautiful. So this is my second equation. I have this equation, I have this equation. I think I know what to do. This is first equation, this is second equation. What am I going to do? I think I'll just add them. So add equation 1 and 2. Why will I add them? Because when I add them, this friction and this friction, I think will get cancelled. This will get cancelled. Yes? Let's try to do this and see what do we get. Okay. So F plus F, small f got cancelled, is MA plus 2 by 5 MA. So this will become 2F is equal to 7 by 5 MA. That means take all these guys on that side. Okay, 5 2s are 10. So 10F by 7M is equal to A. I think this is what we needed. Find the acceleration. So is the answer there somewhere? 10F by 7M? Yes, option C. No, it is not A. Be careful. Yeah, gaming with King Ash, the King Ash. It's not. It's C option. Yep. Yes, Sushruta. That's how you solve it. So what did we do? First, draw FBD, show acceleration, angular acceleration. Then F is equal to MA. That's what the procedure is. Torque is equal to I alpha. A is equal to alpha. Solve it mathematically, you get the answer. There is nothing great about it after a point. Yep. So you just need to get a hang of this. Option C was correct. Let's solve a question which involves even angular momentum, and this will be amazing. So there is a disk of certain mass which is rolling with some speed on a horizontal plane as shown. Find the magnitude of angular momentum of the disk about the origin. Very interesting question. So last lecture I had told you about this. If you want to find the angular momentum about the origin, the angular momentum of rotating and translating body, okay, with respect to O, you have to find that, will be the sum of two terms if you recollect. First, look at the center, see what is the velocity, and by the way, this is your RCM, this is the velocity of the center of mass. So mass into RCM, okay, just once again I'm using small r, so RCM cross VCM plus about the center there will be some angular velocity, so ICM into omega. These were the two terms which I have already given to you last lecture. This is angular momentum of center of mass, MRVCM, plus sitting on the center of mass, I omega. That's the angular momentum with respect to center of mass. Correcto. Let's do it step by step. First term, m is m. Instead of doing this cross product and this angle and all this random nonsense, I know one thing. If I extend the line of velocity, this is my r perpendicular. This is my r perpendicular, and this r perpendicular is nothing but r. This r and this r are equal. So I can just write it as m r velocity of the center. I think velocity of the center, because it is rolling, is just omega, since it is rolling. So that's it. So just put, instead of VCM, just put omega r. That's it. And what direction is it? I think it is clockwise. Okay, so it is just clockwise. I'm just going to put over here. It's clockwise. Next term, moment of inertia of this disk. It's a disk, right? So what's the moment of inertia of a disk? It's m r square by 2, is it? Into angular velocity omega. That's it. So m omega r square plus m omega r square by 2. What is it going to give you? 3 by 2 m omega r square. That's it. That's the final answer. Is it there somewhere? Yes, it is. Done, done or done. Very good. Okay. So what is this? Basically, this question, helped you apply the concept of angular momentum for translating and rotating bodies, and I have combined it with rolling motion. We all know whenever you have a body which is translating and rotating, you have to use these two terms. You first look at this term, which is angular momentum of a center of mass, and this is with respect to center of mass. Then over here I have used the idea that whenever you have r and velocity at an angle, either you split velocity or you split r. Here I chose to split r, and I just chose r perpendicular. Okay, so this was nothing but r perpendicular, which simplified the problem. And sitting on the center of mass, it's just I omega. Just substitute it. It will give you the total angular momentum of the disk about this axis. Very interesting question. Now, this concept will be used for solving complex questions like conservation of angular momentum, which we are going to study in next session. Okay, that's the answer. Divya, क्या नहीं समझ में आया? Do you remember angular momentum? If you remember angular momentum, then you will use it. Yes, Harita, r perpendicular can be used. Yep, Sushmita, option C is correct. Correct. So angular momentum पिछले class में पढ़ाया था. Just watch the previous class. Okay, let's look at kinetic energy of pure rolling. Okay, kinetic energy of pure rolling, and this is again based on a concept which I had told you before. See, when it is rolling, it is basically doing two things. It's the translation of the center. It's the translation of the center plus rotation about the center. Now, whenever you have translation, what is the kinetic energy formula you use? The kinetic energy of translation is nothing but half mv square. Now, here it is the translation of the center of mass, so it is half mvcm square. That is the kinetic energy of just translation. If you assume the entire sphere as a point, and what is the translational energy associated, it will be half m velocity of the center of mass square. Make sense? Similarly, what is the kinetic energy of rotation? This is always with respect to the center of mass. So if you sit on the center, you just see pure rotation. So what is that? It's half moment of inertia about center of mass into omega square. When you add these two, you get the total energy of rolling. So that will be half m vcm square plus half ICM omega square. So this is translational energy, this is rotational energy. Correct. That will give you the total kinetic energy of that rolling object. Very, very important. This will be used for energy conservation problems. So in a way, in today's class, you are just learning the building blocks. Oh, this is how you calculate rolling energy. Or this is how you calculate the total angular momentum. Or this is how you find the force. That will be helpful in other problems as well. Okay, so that's the total kinetic energy of a rolling object. Translational and rotational together. Let's solve a question based on this. Come on, my warriors, figure this out. So there is a uniform disk, and what is it doing? It is having a mass of 2 kg, and basically it rolls. And when it rolls without slipping over a horizontal plane, the speed is 4 meters per second. Remember, the radius is not mentioned as such anywhere. The question is, what is the kinetic energy of the disk in joules? Let's see how many of you can solve this. Sushruta, it's just a coincidence. I mean, it just comes out to be. I mean, there is no reason. Why does S is equal to ut plus half at square? So, there is no reason. It just comes out after you do integration and yeah, all the formulas. Derivation has been already done, I think. So, that's why. Okay, come on, my warriors. Think carefully. What will you do? How do you find the total kinetic energy? Let's see how many of you can do this. This is a simple question. Pretty sure you will get it. So the total kinetic energy will be half mvc square plus half ic omega square. Let's do this. Half into mass. What is the mass? 2. Velocity. How much is the speed? It's 4. So 4 square plus half moment of inertia. It's a disk. So m is 2 into r square by 2. That's moment of inertia. Into omega. Omega is v by r. So it is 4 by, I don't know the value of r. So 4 by r whole square. Now you can see that even though I do not know r, this r square and this r square will get cancelled. So I don't really have to bother about it. 2 gets cancelled. 4 square is 16. Plus 2 also got cancelled. 4 square is 16. 16 by 2 is 8. So this will become 24. Is it there? Yep, it is. Option B. Option B is correct. Done. Okay, so these are how you calculate. These are very good simple questions which will help you understand how to calculate kinetic energy, rotational energy, translational energy. Then you can solve complex problems. Also, we will be having a special session just for problem solving of complex questions as well. Yep, very interesting. Now, let's do this. Very interesting question. And what do we have over here? There is an object, okay, of certain mass, moment of inertia, and it is released from the top. As soon as it comes down, the question is, what's the speed at the bottom? What is the acceleration? What is the time taken to reach? And what's the total kinetic energy? Basically everything. So this is a very common problem, very important problem. Let's see how to do this. Okay, so first of all, obviously start with free body diagram. Without free body diagram, you cannot get anything. So I just drew it for you because this is a standard free body diagram. I mean, we have been doing this again and again. So no point wasting time over there. One is normal, mg. Mg will have two components, mg sine and mg cos, and just shown friction over here. That's it. Okay, these are the only forces, pretty much standard. Let's actually start writing equations. But before that, one simple thing which is missed in this, that is acceleration and angular acceleration. Without that, you should not proceed. Let's write equations. Okay, let's start with net force is equal to mass into acceleration. So over here, normal will be mg cos, but I will not get anything with that. I think in this direction, mg sine and friction will give me m into a, but mg sine is in the direction of acceleration. Friction is opposite to acceleration. So I'll start like this. Mg sine theta minus F is equal to mass into acceleration. Fair enough. Next, net torque is equal to I alpha. Let's see what do we get from that. About the center. Mg sine, mg cos passing through the center, no torque. Normal also passing through the center, no torque. Friction gives the alpha wala torque because friction will give that clockwise torque there. So it is helping and there is no other force apart from that, in fact. So what distance is friction at? It's at a distance of r and it is perpendicular. So beautiful. So r into friction will be, I don't know, alpha. You remember what I can do with alpha? A is nothing but alpha r. So alpha will be nothing but, think about it, alpha will be A divided by r. I can use that. That's very interesting. Now let's see what we can do. I think from this I will get F is equal to I by r square into A. So I can use this over here. Okay, so what I am doing is just using this value of friction over here and see what do we get. So mg sine theta minus friction, which is I by r square into A, is equal to mass into acceleration. So mg sine theta is equal to m plus I by r square into A. Okay, let's divide by m on both sides and see what happens. So I'm just going to divide by m on both sides. Okay, so this is what is going to look like. So I'll just get g sine theta. So g sine theta is equal to 1 plus I divided by mr square into A. That means I figured out the value of A. So acceleration will be g sine theta divided by 1 plus I by mr square. Very, very interesting formula. This is something which you should remember, because this is very common important problem. This is very common and important problem. So please remember the formula for acceleration. Once you know acceleration, you can find everything else. For example, let's say velocity and total energy and time, all of that. Let's see how to get to all of this one by one. I hope this much is clear. This much is clear. So I'm going to erase this because I'm going to need some space out here. Okay, let me just erase this. Okay, now observe this. See, look at this. Total kinetic energy is asked, speed is asked. You know, I'll solve these two first. This one is done. I think I can take care of these two. Right from the top to the bottom, when it comes down, tell me, are there non-conservative forces? Think carefully. Well, there is normal and friction. But will they do work? That's the second question. Obviously, they are not doing work. Normal is first of all perpendicular to the displacement. Second thing, you are also saying friction never does work because it's static and the displacement of the force is zero. Static friction never does work in rolling. I have told you this. So that means mechanical energy should be conserved. And if mechanical energy is conserved, let's just use energy conservation and see what happens. So all I'm saying is friction doesn't do work. Therefore, mechanical energy is conserved. If mechanical energy is conserved, here it just had potential energy. So the potential energy, gravitational, will get completely converted into the total kinetic energy, which is translation plus rotation. That's it. So therefore, how much is the potential energy? I think height is given, maybe. Okay, I think I have to assume it. So mgh, let's just assume that the height of this plane is basically h. So mgh is nothing but, you know, the kinetic energy of translation plus rotation. That gave me the fourth answer. That's it. That's the fourth answer. Done. Now that will also give me the second answer, because mgh will be sum of the two energies, which is half m v square. Because when it comes at the bottom, remember, it will not only have velocity, but it will also have angular velocity. So half mv square translation plus half I omega square. Okay, so I think I know what omega is. Omega is v by r. So let's just do that and see what do we get. So half m v square plus half I omega square is v square by r square. So I can take v square common and even half common. So v square by 2 into m plus I by r square. Great. So I think I will divide by m on both sides maybe. So I will get GH is equal to V square by 2. Again 1 plus I by mr square. Shift these people on the top, okay, bottom, below, whatever you want to do. So V square will be 2GH, the whole thing divided by 1 plus I by mr square, and therefore the value of V will be root of that. That's it. I think you got the value of velocity as well. So that's how you get velocity, and once you get velocity, I think the only thing left which is there over here, time. How do you get time? Use kinematic equations. V is u plus at. You'll get that? Will you be able to do it? V is equal to u plus at. You know u is 0. Okay, u is 0. Acceleration, we just got it here. Time I don't know, velocity I found out. That's it. As simple as that. Okay, that's easy. That's not difficult. If you don't like that, then you can also use V square is u square plus 2s. Sorry, s is ut plus half at square. You can use s is ut plus half at square also. One and the same thing. You will still get the same answer. The final answers which come out to be is something like this. Speed comes out to be this, exactly what we got. Acceleration g sine theta upon 1 plus I by mr square. Time you get this, like I give you as homework. And obviously the total kinetic energy comes out to be mgh, as simple as that. Very interesting. Okay, Bhavish, unfortunately Google Slides does not allow us, I mean, whatever you write, it gets erased by the software. I mean, there is no functionality in Google Slides. That's the problem. Okay, so that's why I always post the answers. Number two, I don't want you to actually look at the solutions, because that's a very bad habit. I mean, you should always try it out on your own, and you can always watch the video. This video is never going to go away. Anytime you want to watch it, you can definitely watch it. You can just pause and keep the solution on the screen. Okay, Bhavisha? Those are the two reasons. And because when you look at the solution, you feel that you know it, but when you try it on your own, then you realize, oh, actually I don't know it. Okay. The last few things before we close this chapter, or before we close this session. Rolling down an inclined plane, I want you to think about it. If I give you multiple objects, if I give you multiple objects, like, by the way, ESD, Subhanshini, I can do that, but right now it's of no use, because just learning formulas will be of no use. You know, probably that will help you during revision later on. Now you have to learn the concepts. So concepts and formulas are very different. If I give you a sphere, if I give you a ring, if I give you a cylinder, if I give you a disc, and all these objects, and if I start them at the same time on an inclined plane, there's an inclined plane and there are all these objects together, you know what? Who will reach first? Who will have more acceleration? Who will have more speed? Who will come down really quick? If I ask you these questions, this will become very, very interesting. And I'll tell you how to solve it. It's very easy. See, no matter which object you talk about, okay, which object you talk about. See, I just told you the acceleration formula. And what is the acceleration formula? It was g sine theta upon 1 plus I by mr square, right? In general, for any object, how does the formula for moment of inertia look like? mr square by 2, mr square, 2 by 3 mr square, 2 by 5 mr square. That means always the moment of inertia formula has some factor, let's say I call it as gamma, into mr square. Isn't that how the formula of moment of inertia looks like? Some factor gamma into mr square. It could be half, it could be 2 by 3, it could be 2 by 5, it could be 1, I don't know. So how about writing it like this? G sine theta divided by 1 plus gamma into mr square divided by mr square. Interesting thing to note, mr square cancels, and I'll be just left with g sine theta upon 1 plus gamma. That's it. This is a better way of remembering it. This is a better way of remembering. Karthi, you'll easily need one lecture and then one more, I think, at least problem solving sessions and maybe advanced session and all that. So easily 2 lectures minimum. Now, what you have to see is there is no mass and there is no radius. So this is independent. It's independent of mass and radius. Meaning it only depends on the shape. Whether it is solid sphere, it's hollow cylinder, whether it is a ring, whether it's a disc. That's all. That's all. Nothing else. It's got nothing to do with the mass. It's got nothing to do with the radius. That means if I take a solid sphere and if I take a big solid sphere, both of them will come down in the same time because gamma will be same. It looks very unrealistic, but it will be true. A small sphere and a big sphere. Both are solid, doesn't matter what the mass and what the radius is, it will come at the same time because acceleration will be same, their speeds will be same. Very interesting. But if you compare other things gamma, like a ring, for a ring gamma will be 1, for a disc gamma will be half, for solid sphere it will be, what is the gamma? It is 2 by 5. For hollow sphere, what is it? Gamma is 2 by 3. For a disc, I told, for a cylinder, it's same like a disc or a ring. Based on gamma, acceleration will be more or acceleration will be less. Who has the highest gamma? Ring. Correct? So ring has the highest gamma, so acceleration is least. So gamma is max for a ring. That means acceleration is least or minimum for a ring. If acceleration is less, that means it will slowly accelerate. The time taken is most for a ring. That's very interesting. What an interesting thing. What an interesting thing. So the one which has the least gamma, which is solid sphere, it will come down first. So I want you to figure this relationship out. Okay? I have posted the answer, but use the logic and you can build this comparison chart. Whose acceleration will be more? Whose velocity will be more? Whose time will be more? You can figure this out. And I will show that to you. Look at this. Look at this race. It's a beautiful race. It's a beautiful race. Look at this. Beautiful. Isn't it? Amazing. Look at that. Observe it carefully. This is solid sphere. This is a ring or a hollow cylinder. This is solid cylinder. I think that one is solid and the red one is hollow. The red one is hollow. This is solid. This is a ring or a hollow cylinder. This is a disc or a solid cylinder. You can see ring comes slow and the solid cylinder comes first. What a beautiful question. Jaya, you can find my micro courses for NEET. Yeah. Yes, ring will come last. You can see that. Time taken will be more. Bindu. Correct. Time taken is more for a ring. Interesting? What a beautiful question. Excellent. Now, okay. There are actually, honestly, yeah, there's one announcement that I want to make, that if you have not yet registered for the mega scholarship admission test, yes, please do that right now, and you'll get guaranteed scholarships, and it's open for all, and you can win lots and lots of prizes. Please do that, and I will post, you know, the syllabus, and you can also pause the screen and you can check out the, you know, correct pattern of the examination, just in case you are interested to write the examination, because that will give you lots and lots of scholarships. So please do that. Okay, so I hope you had a great time. We'll be having a separate problem solving session, and let me tell you, do not forget to post your answers in the comment section. I'll just show you the homework questions as well. Yeah, where are the homework questions? Yes, it's here. Yeah. Okay, yeah, this is the homework question. Let me show you the homework questions. Look at this. This is the first homework question. So this is your first homework question. Okay, then this is your second homework question. Post the answers in the comment section. And then this is your third homework question. Okay, and this is your last homework question. Okay, this is the last homework question. So 4 homework questions for all of you. Do not forget to post the answers in the comment section. Answers and solutions will come up in the Telegram group. Okay, I think it's time for Shimon sir's class as well. That's it from my side. Have a great time. Take care, stay safe, stay at home, and love you all. And please keep coming back and get your friends along too. All right, bye bye. Have a great time. Hasta la vista.